Our world is full of motion. You can see moving things everywhere. Cars running on the road, people walking, birds flying in the sky, even the needle of your clock. But how do we decide which objects are at rest and which are in motion? If you observe closely, the objects which are moving are changing their position as time passes, and the objects which are at rest are not changing their position. So, we can say that if an object is changing its position with time, it is moving. And if it isn't changing the position, then it is at rest. But is it that simple? Imagine you're on a bus. The person sitting next to you appears to be at rest. But for someone standing on the ground, the same person appears to be in motion. Let's understand this in detail. Inside the bus, you are the observer who's judging the state of motion. Since the person is not changing position with respect to you, he appears to be at rest for you. But when an observer is on the ground, the person sitting on the bus is changing his or her position with respect to this observer. So, the same person appears to be in motion. So, we have seen that the same person can appear to be at rest for one observer and in motion for another observer. Even stationary things like trees or buildings, which always appear to be at rest, are actually moving constantly. If you observe from outside the earth, you can see that the earth is moving, and so are the trees and buildings with it. So, whether an object is at rest or in motion depends on the observer too. For the sake of simplicity, in our lesson, we will talk about motion with respect to earth, which means that if something is stationary when observed from the earth's surface, we will consider it to be at rest, like this tree. So far, we know that an object is in motion for an observer if it is changing its position with respect to that observer. But how do we define the position of an object? Let's understand this with a real-life situation. Suppose you ask your friend for the location of his house, and he only tells you that it is far away. Well, just this information won't help you. Even Australia and Antarctica are far away. To reach your destination, you need to know exactly where it is. So, you ask your friend for any landmark nearby, and he tells you it is close to your school. Good! Now you have an idea where his house might be. You have a reference point. But still, you don't know how close it is to the school. His house might be next to the school or 2 kilometers away. So, you further ask for the distance from the school. And your friend says that his house is 500 meters away from your school. Great! Now you have some more information. You have the distance from the reference point. But wait, there are many locations which are 500 meters away from your school. You still need some more information to reach the exact location. And that information is a sense of direction. Which direction? You ask your friend. North. He tells you. So when you get the information that your friend's house is 500 meters away from your school in the north direction, you know the exact location of his house. So these are the three things you need to locate the position of an object. First is the reference point, which is the starting point from which you measure the distance. And in science, we also call the reference point the origin. Second is the distance. That is how far an object is from the reference point. And third is the direction in which the object is from the reference point. If we change the reference point for defining the same position, the distance and direction also change. Let's say now we take this mall as a reference point. Then your friend's house will be at a distance of 4 kilometers along the east direction. Locating a position is a lot easier if we have to deal only in one dimension. We can take any point as a reference point or origin on this straight line and mark the distances from the origin. So this is at 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, and so on. Now, in one dimension, we have only two directions, forward and backward, which we can denote with a positive and negative sign. So, if a person is at 3 kilometer distance left from the origin, its position is minus 3 kilometers. And if he is at the right of the origin, its position is 3 kilometers. So, anything at the left of the origin is a negative position and anything at the right of the origin is a positive position. So, what is the position of this tree? It is at minus 5 kilometers. And the position of this kid? It is at 2 kilometers. Using distance and sign, we can mark the position of any point on this line. The system for locating position is also called the number system. And it is really useful in defining the position when we study motion in a straight line. In a straight line motion, an object can only move forward and backward in a straight line. So the motion of a car on a straight road or the upward and downward motion of a lift are examples of motion in a straight line. But the motion of an athlete around a ground is not a straight line motion. Okay, now I have a question for you. If a car moved from here to here, what was the initial and final position of the car? And how much distance did it travel? Think about it, but for now, let's have a quick recap. We learned that motion is the change in position with time. One object may be at rest with respect to one observer, but in motion with respect to another observer. To locate a position, we need a reference point, distance from the reference point, and direction. We can locate any position on a straight line with its sign and its distance from the origin. I hope you've enjoyed this lesson. We will learn more about motion in the upcoming sessions. Till then, keep observing moving things around you.